Hello. We shall start. We are happy to be here presenting our work. Let me share with you that a few months back, when we were about to apply for participating in the Devoxx event, we participated as visitors. At that time, the initiative that we're going to present today was in a very initial state, and we were not even thinking presenting it here or anywhere else. But a couple of months later, we've seen some amazing results, and that's why we are here to share those results with you. My name is Michalis Kollias, chapter leader for digital commerce applications, and together with me is Zisis Michalaris, a senior software developer, and we both work for Cosmote Telecom. Today we are going to present the methodology of transforming a real retail e-commerce application in an amazing speed, leveraging AI agents and engineering methodologies. To understand the challenge that we had in front of us, the e-commerce application that we modernized was not just another application. It was an e-commerce ecosystem with many integrations, with capabilities that were built over 10 years by a dedicated team, and that accounts 1.2 million lines of custom code, and it serves over 120 million visits per year. But let's have a step back to see what we had in front of us. We can think it as a 3-floor building, starting with the first floor, which is the foundation layer, where all infrastructure, databases, configuration, and data that lives there. Right above is the application layer, which is the e-commerce monolith with all the out-of-the-box capabilities and modules. And in the top floor is the customization layer. This is where things become very interesting. We're talking about 1.2 million lines of code built by a dedicated team over 10 years. This is a tall and robust building, but it's difficult to evolve, it's difficult to maintain and to scale. And this is why we had to modernize it. Legacy code. Is there anyone enjoy working with legacy code? Okay, normally engineers, they find legacy code as something bad, as an obstacle, as a technical debt, as something that they don't want to deal with. It takes 3 to 10 times to reverse engineering legacy code instead of writing something from scratch. But we have an opportunity here. AI agents can understand, process, and analyze legacy code really fast. And they can also extract specification from it. And we don't talk about any specification. We talk about specifications that are proven in production and that are 100% complete. So for us, legacy code is our precious specification. In order to modernize our e-commerce, we had 3 options. The first option was to use the traditional software development lifecycle. This is the safe approach, but time-consuming and complex. The second option was to buy a new product. this could potentially be faster. But it has certain limitations, and we bind into a certain vendor. And the third approach was to leverage AI agents in order to extract specifications from the legacy system and to help us building the new one. So we selected the most ambitious, but the one with the highest potential option. And how we managed to do that in 6 months? First of all, we started with what we already had, our precious legacy code, our precious specification. Together with the help of agents, we process the legacy code and we design our new architecture, together with the architect team and the blueprint, the enterprise blueprint of the company. We created the guardrails, all the set of instructions. We built a team. We started small, and gradually we scaled from one to 5 people. And then we started working iteratively, feature by feature, developing the new platform. Then we validated the results, and we end up with a new modern e-commerce application. So let's deep dive into the approach.
Hi, everyone. So starting from that 3-floor building we saw earlier, the question was, how do we move to a new microservice architecture? The process is straightforward and has 2 steps. The first step is the reverse engineering using AI. AI reads the legacy code and builds an understanding of how the legacy system works. It identifies structure and how data flows through the system. Then comes re-architecture. Based on that understanding, AI proposes a new design. At this point, AI is not guessing. We have provided our company blueprints, guardrails, and target vision, so it can work within boundaries. The most important part here is the human validation. Engineers reviewed everything area by area. So no, AI is not replacing architects. It just helps us to move forward faster with a better insight. So let me show you how we actually build this. I will keep it focused on the stages we followed and the loop we repeated. As you see on the left, over the last months, we have been working on these 4 stages. The first stage is the foundation stage. Over here, we imported the legacy code, set up around 30 containers, and mocked every external system. So agents can run the code, agents can break the code, and agents can fix it safely. The second stage, it might sound a little bit boring, but it is very important. Over here, we build simple features, and we also start with static pages like About Us. This might sound boring, as I said, but it is very important. And why it is important? Because agents learn our patterns so they can use them later on. The third stage is the most challenging one. It's the most challenging one because over here we build the business logic and the integrations with other systems. Logic is spread across code, databases, configuration, and hidden behavior. So agents analyzed the code, observed runtime behavior, and we iterated heavily. The last and the 4th stage was the back office, where at this point we had already built our APIs and our domains, and they were already structured. So building the admin tools was very simple. But the real engine behind this process is the loop you see on the left. It starts, as I said previously, with the code understanding. Over here, agents read the code and they build a model. From that model, we extract the logic. Then humans step in and we add business context and we create the user stories. Implementation is like pair programming. Agents generate code, engineers guide them. After this step, and a very important step is the human validation. We review and validate everything. Then we ship, observe, and feed the results to the next cycle in order to repeat. And what comes after building end-to-end testing? And of course, we use the AI agents. A lead agent that coordinates other agents that are specified in catalogs, journeys, and flows. The process here is simple. It has 3 steps. The first step is that we build a baseline from the legacy side, and we observe. We see performance, we see results, we see responses, and we have all this into a structured report. The second step is that we repeat the same scenarios on the new platform. Every scenario has to be repeated exactly the same way. Last, agents analyze and compare the results and generate another structured report. So the core principle here is this, that the legacy side defines the behavior unless we explicitly decide to change it. On top of that, of course, we added some already known patterns, like unit testing, integration testing, static analysis, and of course, real UAT phase with users. And a quick note on tooling. We tried several options, but what worked well for us was Cloud Code with Opus, mainly due to reasoning quality. On top of that, we added some other tools, like for browser automation, for semantic code navigation, and for documentation. So this gave the capability to agents not to only read the code, but to interact with it. Having working like this for several months, some patterns were clear for us. So what worked for us? Definitely, I would say the feature level README files, giving to agents business context, improved the performance and the output results significantly. Second is the browser-aware agents. So giving agents the capability to see the UI was very helpful. Also, iteration. Observe, refine, and repeat. This was very important. And last, human checkpoints remain critical. On the other hand, we also face some hard technical problems. The first one is giant data structures that we had to split them for processing. Also, at the beginning, outputs were inconsistent, so we had to try new models. Hidden behavior was everywhere, because someone fixed a bug years ago, never documented, and just released it to production. And of course, models' context limits. This led us to decompose the system into smaller parts in order to be able to analyze it. So the honest behavior behind this is that AI gives you speed in the straightforward 80%, but the remaining 20% still needs engineering judgment. So, to wrap up, what we are presenting today is a methodology. This is not tied to a tool or to a model, and the key idea behind this is this. The first one, treat the legacy code as your specification. The second one is that, first one, treat the legacy code as specification. The second one is to work in iterations. Repeat, repeat, and repeat. This is how you will see better results. And the third one is that engineers should have the decision above all. Thank you for listening us. We're happy to take questions here later on in the booth.